Assalamualaikum and hello. In this video, we are going to learn how to determine the electronic configuration based on ionization energy. There are two methods here. Method 1, we are going to compare with ionization energy ratios. And method 2, we are going to compare based on ionization energy differences. And please take note that the ionization that you need to find out only for S block and P block elements only. So maknanya kita akan gunakan group 1, 2, 13 until 18 sahaja. It is not applicable for D block elements. So we are going to start by using method 1. I will determine the IE ratio. So bila kita cakap tentang ratio, usually semua orang faham kita akan bahagi. We are going to divide the value. So we got first ionization energy, second IE, third IE and fourth IE. So these all are the values that you need to find out. So I'm going to start the ratio IE2 divided by IE1. So I have this value. After that, I'm going to continue IE3 divided by IE2. Biasanya saya akan gunakan nombor yang besar lah. And after that, IE4 divided by IE3. So you can see that between 1.93, 8.45 and 1.41, 8.45 is the highest one. And you can see that there is a sudden increase compared to another value because this one starts with 8. However, another two ratio, you got the value starts with 1. So I can conclude right now, IE3 over IE2 has the highest ratio due to the sudden increase in IE3. So kita punya value IE3 lah yang paling banyak, yang paling tinggi. Then, from this statement, you can also conclude that IE3 dekat sini bermaksud elektron yang ketiga is removed from inner shell electron. So, when the third electron is in the inner shell, how many valence electron? So, based on the first question, we can say that 2 valence electrons are present for atom X. So, we can determine the group of atom X, which is group 2. Next, second question, it asks you to determine the valence electronic configuration. In this case, we don't even know which energy level, so we cannot determine the value for principal quantum number. But we need to write the VEC. So in this case, you can write it down as general, as in NS2. So this is the answer for example 11 by using method 1. How about using the second method? This is where I need to choose based on differences in ionization energy. So you can see that based on this part, saya akan tolak because we talk about difference. So I have IE2 minus IE1, IE3 minus IE2, and IE4 minus IE3, so that I will get all of them in positive value. So you can see that the difference value between 3 of them, you can conclude IE3 minus IE2 has the highest difference. So dalam kes ni kita guna yang tolak lah sebab we talk about difference. Kalau method yang sebelum ni kita guna bahagi because we talk about ratio. So get back to this part, we can know that there is a sudden increase in IE3. So it shows that the third electron is removed from inner shell. Dan reasoningnya masih lagi sama macam method yang sebelum ni. Cuma cara untuk kira adalah sedikit berbeza because we use based on differences. However, it doesn't matter which method yang awak akan guna, you still get the same answer. Now, let's try one more example. I have here 5 successive ionization energy in kilojoule per mole for atom M. So right now, you need to determine the electronic configuration for valence electron for M, group number for M, and the real or full electronic configuration sekiranya M is in period 4. Now let's do this one by one. Usually I will choose my method using method 1 because method 1 ratio dia mudah sikit sebab nilai dia tidak terlalu besar. But kalau awak prefer untuk use method 2, tak jadi masalah. So let's use the method 1. So I will have all those value divided based on their respective ratio. So we got 4 different values for the ratio, and you can see that 3.67 here is the highest ratio. So another style kalau awak nak explain, kalau awak nak guna ayat yang lebih panjang, based on this case, fifth electron is in inner subshell. So you can write it down, first, second, third and fourth electron are removed from the same subshell ataupun the valence subshell. And since IE5 over IE4 have the highest ratio, we can conclude that 4 valence electron are present. And the fifth electron is removed from the inner subshell. Dalam kes ini adalah inner core. Hence, sudden increase in IE5. How much the increase? It is 3.67 times than IE4. So, boleh tak kita conclude for the valence electronic configuration right now? Because we have 4 valence electron. So, kita tahu dalam s orbital maximum 2 electron. So, dia akan gunakan ns2. We got 2 more left. It's going to be filled in np orbital. So that's why VEC for atom M is ns2 and p2. You can see 4 valence electron here based on the same energy level. Dalam kes ini kita tak tahu lagi energy level yang keberapa. Now, we can conclude for the second question, this element is in group 14. And the third question, dia minta full electronic configuration sekiranya M is in period 4. So now you can fill up this one as VEC for S2 for P2. The rest of the orbital sebelum 4s2 dan 4p2 are fully filled with electron. So the full electronic configuration for M will be 1s2 2s2, 2p6 3s2, 3p6 4s2, 3d10 4p2. So kalau awak nak tulis 4s2 dahulu sebelum 3d10 tak ada masalah. Cuma syarat dia sebab dalam kes ni saya nak tunjuk same energy level lah. Sebab tu saya kumpulkan n equals to 3 all together at the same site. But please follow the afbal. So that's it for this video. I hope all of you can know how to compare the ionization energy based on ratios or differences. So that's it for this video. I will see you in the next one. Bye!